So hello, everyone. My name is Lucas Lima Vieira, and this is the work I developed for my dissertation in the A+ program, which is entitled Coordinated Specification and Quantity Takeoff through Digital Modeling. I would like to start by presenting the question that was the foundation for this work development, which is how to engineer beam-based specification and quantity takeoff process to make them more automatized, accurate, integrated, faster, and cheaper. The problem had some outspread and was based on a real need of the architectural firm Marta Campos Atelier de Arquitetura, which is a BIM A+ partner. And besides that, as a justification and motivation for developing this work, even though BIM-based specification and quantity takeoff are proved to be more efficient than traditional methods, there are still many opportunities for advancements in digital processes oriented to these two BIM uses that could make them more collaborative, integrated, and with a higher degree of digitalization. Also, existing tools are expensive and not that customizable. Normally, the company adapts its workflow to the digital solution and not the other way around. And the possibility to deal with a real problem with a practical approach also motivated me to conduct this work. Regarding the objectives, from the foundation question, it was established some goals. The primary one was to develop a framework for BIM-based specification and quantity takeoff. And from the framework, the development of a digital solution through programming that would enable intelligent automated extraction of information from a digital model, coordinating this data with a database through a classification system. In the end, the solution would produce a coordinated report for specification and quantity takeoff. In Portugal, this report is commonly known as Mapa de Trabalhos e Quantidades. So the methodology was structured into four main topics: the literature review, designing the framework, programming, and testing real case scenarios. So I will start from the literature review that based the framework developing. And from here, I will highlight two important statements. The first one, a digital solution is just possible by using standardized information, allowing it to be interpreted and processed by machines. And also modern activities need some guidelines and rules that will drive the information to efficiently produce the expected deliverables for coordinated specification and quantity takeoff. So regarding the topic, designing a framework, the framework design was based on the partner company, Marta Campos Atelier de Arquitetura, and was divided into three stages. The diagnosis, which mapped the current process for producing the coordinated and specification report, considering that they also set up a preliminary cost estimation. The assessment evaluated the existing workflow, analyzing its pros and cons, and finally, the framework proposal established the guidelines that were used to develop the digital solution. From the diagnosis, it was reported that even though they already performed BIM-based specification and quantity takeoff at Marta Campos, their existing workflow still requires some integrations to be processed in order to convert the output information to be useful in the following step. This integration process were done mostly manually or semi-automatically. So after the diagnosis, it was made an assessment of the as-is process that identified the strengths and weaknesses, indicating what issues should be addressed to enable the development of the digital solution further. Here, I highlight the fact that they already had a specification database and an object library in compliance with NBS standards and UniClass 2015 classification system, respectively. And these two factors were fundamental for the intended automatization. On the other hand, many different platforms and steps require integration to be processed to shape the data to be used as an input for the following action. The information is not synchronized in now involved platforms, and sometimes this information was scattered in different sources and gathered by hand in the final coordinated report. The classification codes used by Marta Campos have a suffix which provides deeper levels of classification, complementing the UniClass 2015 code. However, this suffix was inconsistent once there was not a clear pattern for them, which would mean some obstacles for machine reading. Lastly, the database, the specification database, was built and managed in a tool which is not adequate for the purpose. And instead of a relational database management system, the data was stored in a spreadsheet. Response to the addressed issues, found modern problems were addressed. In the case of Marta Campos, most of them were related to objects and activities which do not have a graphical expression in the BIM model, but that needed to be expressed in the coordinated specification and quantity takeoff report. So the workflow was developed aiming to decrease the number of required steps and the mitigation of manual and semi-automatic interventions. Also, the classification code inconsistency was approached by standardizing the suffix used to classify the object activities in higher levels of classification. And lastly, it was implemented a proper relational database management system, established a new structure for it with new tables and queries. It was also created a graphical user interface for managing the storage data. And after concluded the framework proposal, the programming stage began. And the digital solution was written in Iron Python language, plus XAML language for some specific graphical user interface, used to receive some user inputs. And it relied on Revit API and PyRevit library to establish the connections between the scripts and the BIM model. The digital solution works as an add-in of the authoring tool, and it's divided into two models. The first one performs the check and invalidation of the BIM model, and the second generates the report itself. The first model checks if there are objects not classified by a classification code, if there are objects without correspondence in the database, and if there are objects without indication in the database or the physical quantity the script must read to get the desired quantities. The second model, the main one, collects the objects from the BIM model, filtering them by types and project phases. The script gets their classification codes and looks for the correspondence in the database. Lastly, it extracts the quantities from the BIM model. The matched information obtained from both the BIM model and database is coordinated and combined into a list. And this script reorders and organizes this list based on the classification codes and the report template used by Marta Campos. In the end, it generates the coordinated report for specification, quantity takeoff, and preliminary cost estimation. TIE was the chosen name for the digital solution, once it means attaching and fastening things, putting them together, working also as an anagram for technical information exchange. So I'm gonna play a short video of TIE in action. Not change, okay. So here is the database management system. So it was created some graphic user interface to manage the data, the construction specification data. And here is the authoring tool. So the add-in is already in action. So you are filtering by types and now phases. And the script, it's being executed, like extracting the quantities from the BIM model. And also at the same time coordinating it with the construction specification database, putting all the information together in order to make the report, which is a project deliverable here in Portugal. So here is the final report, comprising all the architectural elements of the project. So coming back to the presentation, so the final stage of the methodology was the testing and validation of TIE in real case scenarios. So this step was important to identify errors and necessary adjustments in both the framework and in TIE scripts. And for this stage, two ongoing projects at Marta Campos were selected. The first one, Project A, was a new single-family house construction in an early design stage. And this choice was made once the BIM model could be driven since for the very beginning of the design process to attain the intended purpose of producing the coordinated specification and quantity takeoff report, also setting up a preliminary cost estimation. Besides, as a new construction at the moment, the script would not have to deal with complexities such as reuse, restoration, demolition interventions, giving me the opportunity to focus only on the core functionalities of the scripts. And once they were consolidated, these main functionalities, it was used the project B for testing and validating. The project was already with all construction drawings about to be issued, which would not allow the atelier to make significant adjustments to drive the model to be used by the digital tool. And furthermore, as a renovation, the scripts would have to deal with the complexities of reusing, restoring, and demolishing activities. In the end, the modeling adjustments required by the framework were incorporated into the BIM model without significant spend of resources. The mentioned interventions we used restoring were measured correctly, consolidating the script, which performed the process successfully. And in this slide, it's possible to see the outcomes of project A, the coordinated report and the visualization of the BIM model, which hides all the objects that were processed correctly by the script, leaving on screen just the ones that required some modern adjustments, such as a missing classification code or the lack of a correspondence in the database. And the fields highlighted in yellow, reports found errors to the user. In this case, the errors were expected once the project and its modeling activities were under development. Here's the same for project B. In this case, there are no errors identified. All the errors were treated by the model activities, and they have the final report. And so to conclude, here are the final results of the work development. So the time to produce the coordinated specification and quantity takeoff report, setting up a preliminary cost estimation by Marta Campos, has decreased. The already BIM-based method as is used to take 5 days to be completed, including the modeling adjustments necessary needed for the process. And now with the re-engineered process, the process to be took just 1 day. The comparison was made using project B, and of course, considering projects with similar scale and complexity, and one person performing the task. There was also a simplification of the information flow, the number of sub-processes and the required changing of platforms decreased, and the repetitive, time-consuming and error-prone routines were mitigated, resulting in more efficiency and accuracy. Also, a proper relational database management system for construction specification was implemented, providing a better way and safer environment for manage this information. And last, the coordinated specification and quantity takeoff report, alongside a preliminary cost estimation generated by TAI, was part of an official project delivery, and it was handed to a client of the architectural firm, and it has been used since then for more other projects. So just to conclude, as for the developments, it would be nice to implement TAI in other real case scenarios to expand its functionalities and repertoire. The same for other disciplines rather than just architecture. The same to the cover of modern issues would be important for firms that doesn't have the same level of maturity as Marta Campos, and to work outside of a proprietary BIM platform, enabling TAI to read IFC models, and also the integration with other external database within which the framework, such as cost estimation or cost engineering and environmental assessment. So that's it. Thank you.